Hi everyone, welcome to Untitled Engineering YouTube channel. From the series of tutorials on antenna and wave propagation lab, this is our tutorial number 6, and in this tutorial we are going to discuss about the design and simulation of conical horn antenna using CST. So the basic concepts about the horn antennas and calculation formulas for designing horn antennas have been discussed in tutorial number 5. So if you have any doubt or any confusion about the basic concepts or about the calculation formulas or about the values that we will use in designing of conical horn antenna, then you can watch tutorial number 5, and its link is provided in description. So let's begin. First of all, as far as the design of conical horn antenna is concerned, we will design it in few steps. The first step will be the construction of waveguide, and in second step we will design conical horn shape, and in third step we will use simply Loft command to merge these two shapes, and finally we will simulate and check the results of conical horn antenna. So let's begin. First of all, start your CST Studio software and just select microwave RF antennas. As you have to design waveguide antenna, so just select waveguide antenna, and then select your start and stop frequencies. For example, if you want to simulate it in between 0 and 10 gigahertz, and you have to calculate E field, H field and far field results at 5 and 6 gigahertz frequencies. So just finish and your project will be started. So step number 1 is about the construction of circular cylinder, which is basically waveguide. So just select circular cylinder and name it as a waveguide. As far as the values of these waveguides are concerned, outer radius is 21.2 and inner radius is 0. Similarly, X center and Y center are 0, 0. Z min is 0 and Z max is 76.2. So 76.2, while material is PEC. So just click on preview and then just press OK. So step 1 has been completed. Now move toward the step 2, and that step is about conical horn shape, and in a similar way we will again define a circular cylinder with some larger values. Okay, so just again go to the modeling and just select circular cylinder and then press escape key. So that will be our horn shape. Now here radius will be 41.8. so outer radius is 41.8. X center and Y center will be 0, while Z min is 107.3. so 107.3, and Z max value is 189.5. Same material will be used, so just click on preview and then just click OK. So now just rotate. So this is smaller cylinder, which is basically waveguide, and this is basically horn shape, a conical horn shape. Now move toward the third step. Third step is to join these two cylinders, and for that purpose we will use Loft command. Okay, so before using Loft command you have to select these two inner faces, and you know that just using shortcut key F you can easily select the faces of these two sides. Okay, so both the faces have been selected. So now go to modeling, and then you can use Loft command here from modeling. Okay, in 2015 version Loft command will be at the start of the shapes, and now in 2019 or 2021 version this Loft command is here on right side. So just use Loft command. Smoothness factor can be chosen as per your choice. Same material will be used. So now just click on preview, and now you can see that these two shapes have been joined. So just click on OK. Okay, so that was our step number 3. Now you have to add all these shapes to further proceed. Okay, so the third step is to make it hollow, and as you know that in previous tutorial while designing rectangular horn antenna, we were using this simple command that first of all you have to select front and back faces, and then from shape tools you can shell solid or thicken sheet, and thickness will be 0.2, or you can check it from manual. In most of the cases it can be selected as a 2, thickness will be 2, so this thickness will be 2, and then just click on preview and just click on OK. So that is basically your conical horn antenna. Okay, so the next step is that now you have to assign a waveguide port. So you can define basically a monopole antenna, or you can say that you can define a coaxial cable here, like in previous video we have designed proper coaxial cable for its feeding, but simply you can simulate it without providing the coaxial alignment here. So just go to the modeling, and then from picks you have to just click on pick edge, and then you have to select its outer edge, and then you have to assign it waveguide port. So just go to modeling and then picks, and you have to pick edge, and now you can pick its outer edge. Okay, so if you have any problem, then just zoom it in and pick its outer edge, and then go to simulation, and then just click on waveguide port. Okay, so just preview and then just click on OK. So that was the design procedure of conical horn antenna, and in this way you can design conical horn antenna. Now you have to simulate, and you have already defined the values of field monitor, and you have already defined its frequency from 0 to 10 gigahertz. So just go to home and just click on start simulation. Okay, so simulation will be started, and it will take some time, so let's wait. Okay, so simulations have been completed, so let's check the results. First of all, go to 1D results and just select S parameters, and now you can check S11. You can say that this antenna is basically operating from 0 to 4.5 gigahertz, because results below than -10 will be considered as a proper working range of that antenna. Similarly, this antenna can also work for almost 5 to onward 10 gigahertz frequencies, as per the results have been shown in this graph. So that's S11 results, and similarly you can check the far field results as well. So just go to far field, and then you have to select 3D model to check its gain. So that antenna is basically providing 10.4 dB's gain, and you can check that this gain is basically directional, because this is directional antenna. Similarly, you can check the radiation pattern of this antenna at 5 gigahertz as well. Similarly, you can check the radiation pattern at 6 gigahertz and gain at 6 gigahertz. So gain at 6 gigahertz is 11.2 2 dBi. So that's all about the design and simulation of conical horn antenna. Thank you for watching. Please subscribe and press the bell icon for latest videos as well. Thank you.